Welcome to the Daily AI News, brought to you by the Day After AI News channel.
We are diving into the news for the 28th of February, 2026. And, usually when we talk about a software update, it is something completely invisible.
Right, exactly.
It's just like a few lines of code or a silent patch, a quick refresh on your phone that you barely even register as you just move on with your day.
Yeah, I mean, it is designed to be frictionless. We have basically been conditioned to expect our digital architecture to change quietly in the background without demanding our attention.
But today, you are stepping into a landscape that absolutely demands your attention because it is entirely different. The updates we are looking at today are literally spilling out into the physical world.
They really are.
So, welcome to this custom deep dive designed specifically for you. Our mission today is extracting the absolute most vital insights from a massive stack of distinct news items from late February 2026.
And synthesizing this much information is a challenge for sure. But, well, when you lay these sources out side by side, the through line connecting all of them is just undeniable.
It really is. We are witnessing a massive paradigm shift. AI is officially breaking out of the chatbot window.
Completely breaking out.
Yeah. We're going to start by looking at mind-boggling digital scale and the birth of autonomous agents.
Right.
Then, we need to confront the severe security and social growing pains of, handing over digital lives to this tech.
Which is a huge issue.
Huge. And finally, we will watch AI literally take physical form in drones, factory robots, and even hardware interfacing directly with human biology.
It is as if the digital neural network we have spent the last few years training is suddenly developing a nervous system in the real world.
That is exactly it. So let's kick things off with the sheer scale of a landscape right now because the numbers are almost hard to process.
Oh, they're staggering.
ChatGPT just hit 900 million weekly active users.
Almost a billion.
Yeah, nearly a billion people interacting with this tool every single week. And on top of that, they have reached 50 million paid subscribers.
Which is just massive revenue.
Right. And they are now backed by a staggering $110 billion private funding round.
Yeah.
That includes $50 billion from Amazon and $30 billion each from NVIDIA and SoftBank. That puts their pre-money valuation at an astronomical $730 billion.
If we connect this to the bigger picture, that kind of tectonic shift in market power immediately creates ripples across the entire sector.
Oh, absolutely.
I mean, when OpenAI takes on a major new partner like Amazon, the industry understandably starts asking questions about Microsoft's position.
Right.
Given that Microsoft basically funded the foundation of this whole era.
Which is exactly why Microsoft immediately issued a joint statement to reassure the market.
They had to.
Yeah, the statement clarified that despite the new funding, Microsoft retains exclusive IP licenses across OpenAI models. Furthermore, Azure remains the sole exclusive cloud provider for what they call stateless APIs.
The stateless APIs.
But I want to pause there, actually. For those of us who aren't enterprise cloud architects, what exactly is a stateless API and why does Microsoft care so much about controlling it?
It is a really crucial distinction. So in computing, state refers to memory, like remembering what just happened.
Okay.
A stateless API means every single time you send a request to the AI, it is treated as a completely brand new interaction.
So it has no memory of you.
Right. The server doesn't remember your previous question. It takes your prompt, processes the math, spits out the answer, and then immediately forgets you.
So it's really just a raw computational transaction.
Precisely. And by maintaining exclusive control over those stateless APIs, Microsoft ensures that the foundational compute layer, the actual raw brainpower of the model, stays firmly rooted in their Azure data center. They don't get entangled in Amazon's specific application memory or whatever consumer-facing wrappers Amazon decides to build.
That makes a lot of sense.
And furthermore, the contractual definition of AGI, artificial general intelligence, and the board's mechanism for determining when it has been achieved, well, that remains entirely unchanged by this Amazon money.
Okay, let's unpack this. Because 900 million users and massive data centers are one thing, but how are people actually using this infrastructure?
That is the real question.
Because we have moved way past just asking a chatbot to write a polite email to a boss or, summarize a PDF.
Oh, definitely.
Enter Perplexity's new computer tier. So for $200 a month, a tier they're calling Perplexity, Max users get an agentic tool running entirely in the cloud.
Right.
It doesn't just answer questions, it independently executes complex multi-step workflows. And it does this by dynamically orchestrating 19 different AI models.
This represents the fundamental shift from generative AI to agentic AI.
Yeah.
The system itself evaluates your goal and decides which specific intelligence tool is best suited for each subtask.
I actually like to think of it like hiring a general contractor to build a house.
That's a good way to look at it.
Right. You don't just hire one person with a hammer to do the plumbing and the framing and the electrical work. The contractor looks at the blueprint and brings in a specialized plumber, a specialized electrician, and a framer for different rooms. Perplexity is basically doing that with AI models.
They are.
If your prompt requires visual outputs, the agent might route that specific subtask to Gemini Flash. If it needs complex coding, it calls in Claude 3.5 Sonnet. For medical research, maybe it taps GPT 5.1.
And it creates temporary subagents to handle specific problems within that larger workflow.
Wow, sub-agents.
Yeah, so it might dispatch one subagent to scrape legal data, another to run a statistical analysis, and a third to generate a finished website visualization. Then it combines them all before showing you the final result.
Okay, I understand the utility, but I have to push back here on the business model.
Okay, go ahead.
I am looking at the economics of this. Compute is incredibly expensive.
It really is.
Spinning up 19 frontier models simultaneously to handle one user's complex research project is not cheap.
No, not at all.
So how can Perplexity offer infinite automated multi-model routing for a flat subscription of $200 a month without just setting piles of cash on fire?
Perplexity executives claim they can maintain high margins on these user fees through highly efficient routing.
Efficient routing.
Right. The AI isn't sending every single query to the most expensive model. If a subtask is incredibly simple, like, say, formatting a date string, the router sends it to a highly modified, incredibly cheap open source model.
Oh, so it saves the heavy lifters for the hard stuff.
Exactly. They only spend the expensive compute tokens on the hardest parts of the problem. They are betting that power users need access to multiple models, but absolutely do not want the friction of managing 19 different $20 subscriptions themselves.
Which makes sense. And this tracks perfectly with how human behavior is fundamentally adapting to these tools.
It does.
The Allen Institute for AI, or AI2, just released their ASTA dataset.
That was a fascinating release.
It really was. They analyzed over 258,000 real researcher queries, and the way human beings are typing into these boxes has completely transformed. Users are not doing simple keyword searches anymore.
The expectation has entirely shifted from retrieval to collaboration.
Right.
According to the AI2 data, queries to these AI science tools are now 7 times longer than traditional searches.
7 times longer.
Yeah.
People are pasting in massive, rigid templates with 15-plus fields, and they are expecting the AI to systematically populate them with data from scientific literature.
Right, they are treating it like an assistant.
Yeah. They are applying advanced prompt engineering techniques, like assigning the AI a specific persona, even when the tool wasn't designed for it. Like one user in the dataset literally asked the AI to devour Turnitin detection bots. I know. They are talking to it like it is a coworker with a personality.
And they consume the results differently, too. The data shows users skip the introduction 43% of the time.
Just jumping straight to the meat.
Exactly, jumping straight to specific data tables. They're treating the AI's output as a persistent artifact, revisiting the exact same reports days later to build upon them.
Interesting.
So the gap between how these tools were originally designed, as simple chat interfaces, and how humans are actually using them as persistent, complex workflow engines is widening rapidly.
So we just saw how AI's autonomy makes it an incredibly powerful tool for getting work done. But that same autonomy makes it a massive target.
Unfortunately.
Right. If you were relying on these autonomous agents to act as your digital general contractor, what happens when the contractor is compromised?
It's a scary thought.
Let's look at the digital reality check we are facing with the ClawJacked vulnerability found in the OpenClaw AI agent framework.
Yes. This vulnerability, which was detailed by the cybersecurity firm Oasis Security, is a perfect illustration of the new threat landscape.
It really is.
They discovered that malicious websites were hijacking local AI agents via a WebSocket connection on the user's localhost.
Okay, let's slow down and translate that for anyone who doesn't spend their weekends on cybersecurity forums. What does it actually mean to hijack a localhost via a WebSocket?
Let's break it down. So, localhost is essentially your computer's private internal network.
Okay.
It is how programs running on your machine talk to each other without going out to the public internet.
Right, makes sense.
And a WebSocket is a technology that keeps a continuous two-way street open between a web browser and a server, or in this case, between a malicious website and your internal computer.
So if a developer had the OpenClaw agent running on their laptop, protected by a password, they didn't even have to download a shady file to get hacked.
No, they didn't.
They just had to land on a website controlled by an attacker.
Yes. The malicious JavaScript on that web page silently opened a hidden door directly into that private internal network. And because the OpenClaw software didn't have any rate limiting, meaning, it didn't lock you out after 3 failed password attempts, the attacker's script could just guess the password thousands of times a second until it got in. Once inside, it automatically registered the attacker as a trusted device. Total takeover.
I think the best way to understand the danger here is to look at the blast radius.
Absolutely.
It's like giving a thief the master skeleton key to an entire corporate office building instead of just the key to the lobby restroom.
That is an excellent way to put it.
Because once they have control of the agent, they don't just have one password. They have the keys to every single room the agent is allowed into.
Exactly. If an AI agent has entrenched access to your Slack, your email, your code repositories, and your enterprise financial systems, well, compromising the agent means compromising your entire digital life instantly.
Instantly.
It is so severe that Microsoft officially issued an advisory stating that OpenClaw should only be evaluated in fully isolated virtual machines.
Because it's too dangerous otherwise.
Right. It represents untrusted code execution with persistent credentials, which is basically a nightmare for IT departments.
And this technology isn't just lowering the barrier to entry for cybercrime. It is lowering the barrier for deeply personal societal harm. Let's look at what is happening in Australia.
Right, the new legislation.
A 19-year-old man named William Hamish Yates is the first person to be prosecuted under a new federal law introduced specifically to combat deepfake. He has been charged with 8 counts of creating or altering sexual material without consent.
Yeah, under these new Australian laws, simply sharing non-consensual deepfake sexually explicit material carries a maximum penalty of 6 years in jail.
6 years just for sharing.
Exactly. And actually creating and sharing it carries a maximum penalty of 7 years.
The data from Australia's e-safety watchdog really underscores why the government felt compelled to activate these laws.
The numbers are alarming.
They are. They report that deepfake incidents involving minors have more than doubled in just the last 18 months. And that's compared to the total number of reports received in the 7 years prior. 4 out of 5 of those reports involve the targeting of females.
The underlying generative technology has vastly outpaced our social and legal guardrails.
It really has.
It has created a readily accessible, incredibly cheap way for people to engage in behavior that destroys lives. The Australian prosecution highlights the very real, very immediate human cost of that regulatory gap.
Right. So if playing whack-a-mole with bad actors after the damage is done clearly isn't enough, how do we fix the foundation?
That's the challenge.
This is where the legislative push for structural equity comes in. Representative Valerie Foushee has introduced the HBCU Artificial Intelligence Research Leadership Act.
Yes. The legislation mandates that 10% of the research institutes established through the National Science Foundation's National AI Research Institutes program be operated by or in partnership with historically Black colleges and universities.
Okay, so I understand the social value of funding diverse academic institutions.
Right.
But from a purely technical standpoint, I have to ask, does the demographic of the researcher really change the neural network's output?
That's a common question.
Like, how does diversifying a lab actually change the code or the safety of an AI model?
It changes it at the foundational mathematical level.
Okay.
Algorithmic bias isn't usually about developers intentionally writing malicious code. It is about the life experiences of the developers dictating the edge cases they even think to test for.
Ah, I see.
It dictates how they weigh the training data and how they define the loss function, which is basically how the AI calculates whether it is right or wrong. So if a room full of engineers has never experienced a specific type of digital harassment or historical redlining, they simply won't design the mathematical penalties required to prevent the AI from replicating those harms.
Because they don't even know to look for it.
Exactly. By closing historical research funding gaps, the intent is to ensure that diverse communities are actively designing those foundational mathematical guardrails.
Now, here's where it gets really interesting. We have spent this whole time talking about agents living in the cloud, cybersecurity blast radii, and software regulations.
Right.
But AI is no longer confined to servers. It is getting a physical body.
The embodiment of intelligence. It is arguably the most complex frontier in the field right now.
BMW is officially deploying Hexagon Robotics humanoid robot, a model named Aeon, at their Leipzig plant in Germany.
Right.
Now, to be clear, this is not one of those single-task, giant robotic arms bolted to the floor inside a safety cage.
No, not at all.
This is a humanoid robot autonomously moving around a dynamic factory environment.
Hexagon Robotics categorizes this as physical AI.
Physical AI.
Yeah, it is the merging of digital intelligence with physical machines. BMW is using Aeon in high-voltage battery assembly and component manufacturing.
Okay.
And the robot has a human-like body that allows a wide range of hand and gripping elements or scanning tools to be flexibly attached depending on the task.
So it is bringing the cognitive flexibility we see in language models directly into the physical world.
Exactly.
It doesn't just run a pre-programmed track. It evaluates its surroundings and adapts its physical movements.
It does.
And is not just walking on the factory floor. This intelligence is taking to the skies.
Oh, the drone swarm.
Yeah. At the Disruptors in the Desert 2026 event, a company called Xtend showcased their Seek and Strike demo. Powered by their proprietary XOS platform, a single human operator can now command a highly synchronized swarm of drones.
Multi-drone orchestration. It is a fascinating leap in human-machine teaming.
I think the best way to visualize this is to picture a shepherd working with a team of highly intelligent sheepdogs.
That's a great analogy.
In a traditional military or industrial setup, you need one pilot intensely focused on flying one drone.
Right.
But in Xtend's system, the human shepherd isn't touching a joystick to fly the drone. They just use a mission planner tablet to define AI-driven microtasks.
And the AI takes over.
Exactly. The AI handles all the heavy lifting of spatial cognition, calculating wind speed, obstacle avoidance, and formation flying. The Seeker drones autonomously scan the area and detect targets. The human just looks at the screen, visually confirms the anomaly, and then the system automatically hands off the complex spatial data to effector drones to take action.
It entirely eliminates the cognitive bottleneck of manual piloting.
Yeah.
The human maintains ultimate decision-making authority, the ethical and strategic oversight, but the swarm executes the mechanical physics of the operation, and the broader market sees massive potential here.
Oh, absolutely. Xtend is currently executing a SPAC merger with JFB Construction to list on a U.S. national exchange under the ticker XTND. So Wall Street is heavily betting on this physical manifestation of AI.
But AI isn't just navigating the physical world we have already built. It is actively being used to re-engineer our environment. Well, look at climate and infrastructure. There is a project out of Singapore called MPR.
Okay.
They have taken 35 years of historical climate data from 1990 to 2025 and refined it down to a hyper-precise 4-kilometer resolution grid for Southeast Asia.
A 4-kilometer grid for predicting the weather across an entire region. That is incredibly granular.
It is.
But why do we need 35 years of historical data just to tell us if it's going to rain next week?
What's fascinating here is the tension between pure math and physical reality. We know that machine learning models can generate weather forecasts much faster than traditional physics-based models like days instead of weeks.
Right.
But neural networks don't inherently understand the laws of thermodynamics. Without strong physics-based historical data to act as training guardrails, these AI weather models will actually hallucinate physical absurdities.
Wait, really? So because the AI is just predicting patterns based on math, not actual thermodynamics, it might output a mathematically perfect model that breaks the literal laws of physics.
Precisely. Dr. Praveen Talay, a climate scientist on the project, pointed out that without a properly reanalyzed climate model rooted in physical laws, the AI could predict things like negative precipitation.
Negative rain.
Yeah.
Like water spontaneously flying out of puddles back up into the clouds.
Exactly. It sees a statistical curve and just follows it below zero.
Wow, okay.
So we need this high-quality, painstakingly refined data set to force the AI to respect physical reality. Once trained, that precision forecasting is crucial for protecting physical infrastructure from localized flash floods.
Which is super important.
And speaking of infrastructure, AI is also changing the actual materials we use to build our cities.
Right. A new study published in Optoelectronic Advances detailed how researchers used an AI-guided inverse design strategy to unlock full-color tunability in solar windows, meaning transparent solar panels that can be customized to match a building's aesthetics, like cyan, magenta, or gray.
Right.
But I need you to explain this inverse design concept. How does an AI invent a color?
Well, in traditional material science, researchers might tweak a molecule, synthesize it, and then test it to see what color it makes and how much energy it absorbs.
Lots of trial and error.
Exactly. Inverse design flips that completely. The researchers give the AI the final desired outcome, saying, I need a material that is exactly magenta, highly transparent, and absorbs maximum UV light. The AI then works backward, calculating the exact molecular structure and non-metallic dielectric coatings required to manifest those physical properties.
And usually, making solar panels look pretty, adding a color filter to them means making them highly inefficient.
Right, because traditional metal filters block the light they need to generate power.
It's a trade-off.
Exactly.
But because the AI was able to invent these specific non-metallic coatings by working backward, it didn't just maintain the energy output.
No.
The AI design actually increased power generation by up to 20% compared to conventional transparent cells.
Which is huge.
We are literally going to be painting our cities with highly efficient solar energy.
We are removing the aesthetic barrier to sustainable infrastructure.
It's amazing. And for our final leap today, we go from the physical environment surrounding us straight into human biology.
The biological frontier.
Deepinder Goyal, the former CEO of Zomato, has just raised $54 million for a new wearable startup called Temple.
This is a remarkable progression. They are aggressively hiring experts in embedded systems, computational neuroscience, and brain-computer interface engineering.
And they are targeting elite athletes.
Yeah.
But this isn't a watch that tracks your heart rate or your steps.
No, not all.
Temple is building a wearable device designed to sit right on the wearer's temple. Its purpose is to continuously track cerebral blood flow.
Which is wild.
We are moving from external biometrics like sweat or pulse to monitoring the literal metabolic demands of the brain in real time.
So what does this all mean when we put the pieces together?
It means we have taken an incredible journey today.
We really have.
We started with the sheer digital scale of a chatbot hitting 900 million users and securing a $730 billion valuation.
Right.
We watched that software evolve into autonomous, multi-model agents that act like digital general contractors, executing complex tasks independently. We tackled the severe security vulnerabilities of those agents, like the OpenClaw flaw that can compromise a local network in seconds.
And the deeply concerning social realities of deepfakes, alongside the legislative efforts to build algorithmic safety by diversifying the engineers.
And then, the software stepped into the real world.
It did.
Humanoid robots adapting to factory floors, swarms of drones handling complex spatial cognition, AI mathematically redesigning the molecular structure of our solar infrastructure, and finally, hardware designed to read the blood flow inside our actual brains.
It is a totally new diagnostic landscape.
It is.
It is, and this raises an important question, something for you to mull over after we sign off.
Okay, what is it?
If startups like Temple are learning to continuously monitor the cognitive load and blood flow in our brains, and platforms like Perplexity are building autonomous agents that can independently execute complex, multi-step tasks in the cloud, how long until these two systems merge?
Oh.
Will the near future feature our wearables subconsciously commanding our AI agents to take over our digital workflows the exact moment our biological brains register fatigue?
That is an incredible and slightly terrifying thought to end on.
It really is.
A world where your brain physically tires out, your wearable detects the drop in cerebral blood flow, and your AI automatically steps in to finish your spreadsheet or answer your emails while you rest.
Exactly.
Well, thank you so much for joining us on this custom deep dive. Keep questioning the world around you.
Before you go, please subscribe to the podcast Prime. And if you enjoyed today's episode, hit like to support us. Thanks for listening and see you next time.